This is Algebra 1, Term 4, Lesson 12, Solving Quadratics. We'll begin with a 3-act task, the big jump. We'll then move to Desmos and solve quadratic equations in a variety of ways. And then we'll finish up by deriving the quadratic formula and using the quadratic formula in graspable math to solve quadratic equations. Let's start with the big jump. The first task is for students to look at this picture and say what they notice. They may or may not know what this is, and that's fine at this point. After they've put their thoughts here about what they notice and what they wonder, the next thing you're going to do is show them a video. I will give you this link, and you can decide whether you want them to have the link or you can just show the video for the whole class. While they're watching the video, they can list several questions on this screen. So let's take a look at the video.
This is blobbing. It involves two people jumping from a diving board onto an inflatable tube and seeing how high they can send someone else into the air. Christian and Patrick will be jumping from a crane and are hoping to launch their pal Elvis as high as possible and into the record books. The current record height is 17 meters. They're aiming to beat that today by firing Elvis 18 meters up into the air, and to do that, they'll have to jump from way up here. Ah! Here they go.
3, 2, 1, go!
Bringen Sie, jetzt müssen Sie das Kissen treffen. Mein Gott.
Ladies and gentlemen, Elvis has left the airbag. He soars like an eagle and then plummets like a dead eagle. So, is it a brand new Guinness World Record? Elvis needs to have reached a height of 18 meters. Adjudicator Anna is checking the GPS reading on Elvis's watch to see how high he flew.
Do we have a reason to celebrate today?
They've done it! It's a blobby record.
Mein Gott.
Okay, so here are some potential questions or ideas that students may pose while they're watching the videos. So several questions would include: who are these men? Where are they from? Some of this is revealed in the video, but they could be asking this before it is revealed, so that would be fine. What record did they break? Who was the former record holder? Why are there two men jumping and only one man flying? Where is this happening? Who manufactured the blob? And by the way, that's what that's called. And have you seen this before? But let's take a look at some of the potential questions you could ask. This is not a fully developed 3-act task. I'm not getting this from someone else. I just found this video and thought, wow, what an opportunity. Okay, on screen number 4 is where we get into the meat of the task. So this is still Act 2, and the kids would go and work with their team to either pose a question and answer it, or you could pose the question and have them answer it. So it's up to you. I'm giving you some scenarios here that I will give you some more information about, and you can then choose if you want one of these or try something else if you've got some other ideas or your students have other ideas. So the first question I would have is, how can we get the height, the initial height of the two men that were standing on the platform? There is a screenshot in the video, and I will put that timestamp here in your teacher notes for you to use, but I didn't want to reveal it. I want them to look for that. What is the approximate height of the platform where the two men were standing? This is one reason I would give them a link to the video, so even if you do decide to show it to the whole class, they will want to play this over and over, looking for different things, because when they're looking at it the first time, they don't really know what they're looking for, but when they're going back to answer a question, they know what they're looking for. So they're going to be searching for particular information like this. They can also mark the time. So they could set a timer and then figure out how many seconds it takes. Well, the timer on the video is probably sufficient. How many seconds did it take for the two men to reach the airbag? So from the time they jumped till they reached the airbag. And how many seconds was Elvis in the air? And how did those two things help you to create a model a quadratic function model for this scenario. Let them play with this. We've already done quadratic regression, so that's one strategy that they could use to create a quadratic model. They could actually use sliders and fit a function to the data using A, H, and K in vertex form. There's so many ways to do this, but I do want them to come up with something here. What was the initial velocity of the jumpers? I don't know that we can figure out Elvis's velocity at this stage. Maybe we can. Maybe when we write our equation, that equation's going to reveal that. And then the initial velocity of the jumpers, if they're just falling and not really jumping up, or did they really jump up? So those are things to ask. And then what are potential quadratic functions to model these jumpers and Elvis as he flew from the airbag? So really good tasks and really practical applications of that vertical motion models, and not one I've seen before. So I think this would be a fun task. You could take an entire day on this task, and considering what we're right in the middle of doing, solving equations with factoring, completing the square and quadratic formula, this has got to be the most grueling part of the course Algebra 1. So it is wise to break it up with some very engaging, interesting tasks like these. So I would recommend it. I would not hesitate to spend a full day on this one. Maybe have them present their findings, and let's just see what they can do. Once we're finished with this 3-act task, we're going to move then to our Desmos activity. So this task is solving quadratics using a variety of strategies. The first strategy is to graph a parabola and graph a line and look for points of intersection. So I've actually set this up as two distinct functions, f of x and g of x. Now on each screen they do have access to the graphing calculator. They are encouraged to use it throughout if they need it. So if they do not know how to graph these manually, they will have access here to do it. But you know, this might be a good time to talk about what do we know the negative does, and what points on the graph do we know are already there. And so they could potentially graph both of these without their calculator. Now once they get their graphs in the right spot, they'll check their graphs. Now if they're wrong, it's going to have that awful error message, and if they're right, it has this funny looking man. Most of these are self-checking, so they will know if they're right. Now this one's asking how many values of x. You know, sometimes you can have 2 values of x. Sometimes you can have 1 value of x, and sometimes there are no real numbers at all. In other words, the line won't cross the parabola. All right, let's go ahead and look at this one. Use the graph of a quadratic function, linear function. Now we're doing the same idea, but this time with one equation. So really the left side of the equation could be one function and the right side could be a separate function. Create 2 separate graphs for this one equation, and using the same idea from screen 1. And then again, graph each side of the equation. They should try to graph these with transformations of x and not look at the calculator until they've tried it, and then they can choose how many solutions. Once they choose the number of solutions, a table will appear where they will actually input the solutions to this equation. Next, we're going to move on to vertical motion. We've done this many times before, and now we have a function h of t. It's already graphed for them, so the bulk of the work is done. But the difference here is there is a question: at what time is the ball 15 feet above the ground? So they would add to this graph a line at the 15, and they should use the line tool, but they will also need to use this Desmos graphing calculator to get that value. They're not going to be able to click on the graph to see it. So tell them to add it to the graph and then find those values using the graphing calculator above. They're also being asked to label the intercepts and the vertex in the graph. So they will label the points here, here, and here, and they will use this graphing calculator to get that information. Once they find those answers, they're going to answer 3 questions. There are 2 different times that the object is at 15 feet above the ground. What are those times in seconds? And there's one point in time when it lands on the ground. What is that time in seconds? In this one, it does need to be rounded to 2 decimal places. These all have X's. If they get them right, those will change into, I think, smiley faces or check marks. All right, for this one, we're using factors to get our solutions, and then when we submit, the graph will check their answer. Doing it again, here are the factors. Can you use the factors to get the solutions? We don't really want them doing anything other than just looking at the equation to get these answers. So if they're having to graph these, we definitely want to have conversations, because those factors do reveal these solutions. All right, now we're going to create our own factors using a box. So I've already kind of gotten them started by putting the x squared term and the minus 14 inside the box. And their goal is to figure out what values of x go in these 2 spaces. And we know the sum is 5x. So let them play with it. And then when they get their factors, they're going to fill these out by just changing the question marks into numbers. And then here they'll type their solutions, and these x's will change to let them know they got them right. Okay, once again, we've got a box, less information this time. If we're doing factors, then 27 does go inside the box, and then our x's need to be split so that they have a sum of negative 12, but you still need to have a product of positive 27. Once they get their factors on their box and they've typed their factors in this little box and click submit, they should type in their solutions by looking at the factors. Okay, now this one's a little bit different, and the question at the top is, what is different? Well, the factors so far have only had coefficients of 1 in front of the x, but in this factor we have a coefficient of 2 in front of the x. So I'm going to let them play with this for a while. It's not just a sum and difference, but they have to take into account that 2x squared. The key here is just to make sure that the factors that are on the side of the box have a product that is equal to the terms inside the box. The question here, what are the solution and what is different about these factors? As always, they can graph these, and they can graph the factored form. And if it's matching, then they'll know that they have the correct factors. And so we are moving towards additional methods. Here we have a function that is not in standard form. So I'm asking them to write it in standard form and type it into this box. Once they've done that, they're going to factor it. Now we have a number outside the parentheses and then 2 factors. So that's something different. And then they're asked for the solutions. Let them play for a while on this screen. They will learn quite a bit just by kind of fumbling through. And again, at the after you've given them plenty of time and they've had lots of conversation and tried several things, you can go over some of these with your students, but just don't begin with that. The time that they spend kind of playing with these factors, looking at the graphs, looking at the solutions, and they're putting it together, and that's where all those connections are happening. When you show them how, all that stops. Those connections don't happen anymore. They have an answer. They kind of put it out of their mind at that point and move forward. So the longer they're willing to persist and to wrestle with these ideas, the better. And I do fully appreciate the frustration of these topics. This is one of the toughest things we teach in Algebra 1. Okay, now it's getting back to inverse operations, and so I've got one solved out. They just have to arrange the steps in order from the initial equation to the final solutions. All right, now let's have some real fun. This one is solving by completing the square. The purpose of this screen is to give students an appreciation for the quadratic formula, because what it does is it takes problems that are like this one, that are crazy nasty, and it turns them into something that is much more accessible and easy for kids to do. So they're going to put these steps in order. This will take a while. I would say screen 12 is probably one of the toughest in the assignment. and then they're going to watch screen 13. Now what I've done is I've created for them a video. It's a little over a minute, and it basically goes through deriving the quadratic formula from standard form, which is this, to the quadratic formula. And they're going to put these steps in order. From standard form will be their first step, down to their quadratic formula will be their last step. And all the steps in between are in the video in order. So they can play it over and over. They can pause it, which is what most students do. They'll play a little bit and pause it and try to arrange them in order. I definitely would put your dashboard up and anonymize your dashboard so that they can see when this is correct. I don't have this one self-checking, so they won't know it's correct if you don't put it up. So please do that. This is literally all I do for this standard where it says, you know, write an equation in this form and use it to derive the quadratic formula. This is that one standard, and it's the only time I touch it at all in the Algebra 1 class. And then finally, we're going to use the quadratic formula to solve this equation. So you definitely, I would say, let them work in their teams on this, and you probably will have to show them something here because, you know, we're not going to do much of this. I only spend a couple of days on these topics, and then we move on. All right, here's the formula. They need to first decide what values are for A, B, and C. I do explicitly state that in the sample response, and they probably should too. My value for A is, my value for B is, and why is that? And my value for C is, and then I plugged it in the formula and I worked it out. They could put it on a whiteboard, which I recommend, and take a picture and insert that in the box. If they do want to do the plus minus, I'll give them a hint. They can copy that, and then if they've got the equation in there, they can paste it in as long as it's an equation. See, I'll show you. Copy this, Control C. Come down here, Control V, and see it'll paste in there. So that's one way of getting that plus minus in their work if they do want to type it out. And that concludes our Desmos activity. Let's move back to the slides. The first thing they'll do in slides is do a problem using the quadratic formula in Graspable Math. They will view this video and it will basically walk them through doing this problem step by step. So let's watch the video. As you can see, they just grab the formula and drag it right to the equation in standard form, and it plugs in the numbers. And then it's just a matter of clicking on the expressions to simplify, and there's the answer. Now what I do is I grab the little dot and cover up some of those steps because I really only need the first step and then the last step where they simplified. On the next slide, I do give them another equation. This time the equation is not in standard form. It's obviously all mixed up. So the first thing they'll have to do is they will have to get it in standard form or the formula doesn't work. It won't allow them to plug in the numbers. So let's go ahead and watch this video. Notice they can't plug the formula. It won't allow them. So what they do is they put it in standard form. Now the formula works. And then everything they do is the same as before. They just click, click, click to simplify. And then grab the little circle and pull up and then cover up some of those steps. And there's your work. They will paste that on their slide. And that concludes our lesson for today, solving quadratics. We only have 2 more lessons before that term 4 exam. Y'all have a great day.